Hi everybody! In this video, we are going to focus on dividing, reducing, and simplifying situations where our numerator is some polynomial and we are dividing by a monomial, or we have a monomial in the denominator, which is something that's not separated by plus or minus signs, vastly different situations. So we like to say that we are dividing when we're dealing with these fractions or rational expressions. We can also call a lot of what we do reducing. We could also call it simplifying. We're probably not going to call anything canceling, because to cancel in algebra or in math means that we are making 0, which would be like positive 5 minus 5 is 0. They cancel out. But in a situation where you are crossing something out from the numerator to the denominator, what you are actually doing is you are either dividing, reducing, or simplifying. But if you just needed to go over a few examples of this, if you wanted some support to get ready for an upcoming unit on all sorts of factoring, if you just wanted a quick review, whatever the case may be, I hope that you're in the right place. First example number 1. 12x to the third minus 32x to the second all over 4x to the second. The method I like to employ whenever I'm doing something like this is something I like to call the pretzel method, and you'll hear me call it the pretzel method a lot. It only really looks like a pretzel when your numerator's polynomial happens to be a binomial, meaning you have two terms. You're separated by a plus or a minus sign. Each oval of the pretzel represents its own division problem or its own fraction. We simplified fractions like 12x to the third over or divided by 4x to the second, which I can write right over here, 12x to the third over 4x to the second. We simplified things like this in lesson 1, where we reviewed the properties of exponents, and a little bit even in lesson 2, where we went over arithmetic with fractions. So coefficients or constants in a situation like this divide as usual, 12 divided by 4, and that would be 3. When we have variables raised to real number, whole number, well, they don't have to be whole numbers, but real number exponents, we employ the properties of exponents that we went over. In this situation, the power or exponent in the numerator is larger than that of the denominator. We are going to do the quotient property, or we will just simply be subtracting the power of the numerator minus the power of the denominator, and then 3 minus 2 is 1. That means we're left with x to the first, or x. I'm not going to write them 1, all right? The second oval has 32x squared in the numerator and 4x squared in the denominator. We're going to do the same thing. 32 over 4, or 32 divided by 4, is going to give us 8. That minus sign kind of just carries along. This is going to give us an 8. You really need to know your times tables. If you're hesitating, if you're grabbing for a calculator, you need to do work, okay? If you are at the point in your math career where you're able to do this stuff, but you don't know your times tables, we gotta press pause and we need to learn our times tables, okay? X squared divided by x squared. Only, I can't reinforce this enough, okay? Only in the situation where your variable and your power match will you get a 1. A lot of times I'm seeing very strange things happening where these 1s are popping up. I'm going to make a video reviewing the content covered on the first quiz, and I will try to point out very common mistakes that were actually already addressed during class time. But hey, we're learning, right? So x squared divided by x squared is 1. I don't need to write 8 times 1. Or you can do the same method, x to the 2 minus 2, which will be x to the 0, and x to the 0 is 1. So right here we have our solution. Next, in case they look a little bit stuck together, we have a negative and a negative right there. We have a minus sign right there. We're going to go ahead and approach it the same way. Now, please keep in mind that it won't always be a binomial in the numerator. You could have a third term, a fourth term, a fifth term. You could have endless terms in your numerator. But in the situation that poly means many, nomials, terms, that your polynomial in the numerator is over a monomial, okay? It has to be a single mathematical expression. You will not have anything that looks like these numerators in the denominator if you're going to do this method. You will reduce each fraction. We're sort of uncommon denominator-ing these problems. We're kind of taking it apart, okay? So first oval right here, I'm gonna write a little bit less down this time. Negative 35 divided by negative 7. That will be positive 5. X squared divided by x. Another way to think of it, which is a little more juvenile, but if it's better for you to visualize, x to the second is x times x, and that x on bottom is just an x. What is left in this situation? I will reduce or simplify an x from the numerator and denominator, and that leaves me with just an x, or an x to the first. Now my second oval, negative 21, negative 7, that will become a positive 3. And that x over x is a 1, and it's gone. It doesn't cancel. It becomes a 1. It simplifies. And there's your answer, 5x plus 3. Now, you always want to keep in mind what was given to you originally in the problem. The problem already had that fraction bar, division sign, whatever you want to call it, and it already had the denominator. And all we want to do is either divide, reduce, or simplify based on whatever the instructions may be saying to you, okay? Nowhere does it say to factor. Nowhere does it say to solve. In fact, we don't have an equal sign, nothing to solve, okay? Next example, 45, x squared over 9, 36 over 9. 9 times tables, you should definitely know. There's the finger trick. We have 10 fingers, right? I hope, well, it is actually, I think, dominant to have 12 fingers, 6 on each hand. But, fun fact, look it up. But if you're multiplying 9 times anything, you can use the finger trick. So if you were doing, say, 9 times 7, well, where's your 7th? 1, 2, 3, 4, 5, 6, 7, right? Put that down. How many fingers can we count to the left? 6. How many to the right? 1, 2, 3, 63. Okay, obviously there's a limit to how far we can go with this, and I don't think it works for those of you who have 12 fingers. Sorry. So if you know that to multiply, hopefully we can work a little bit backwards. 45 divided by 9, that's going to give us 5. X has nowhere to go, so 5x. Plus sign still there. 36 over 9 is 4. All right. I wanted to point out, actually, what we'll see in an upcoming lesson, lesson 7, what we're going to see is when we are placing 7 and 8, when we are placing our own term under here, we will match the sign of this term, this monomial, with the sign of the first term of the numerator. And typically, we are going to look at our numerators in standard form. We should all remember that standard form means that the terms, all like terms, have been combined, and they are in descending, getting smaller, exponential, meaning the exponents are getting smaller, descending exponential order. So this is already, so is that, so is that. The constant would be the last term unless you didn't have a constant. So here is a situation where the sign here does not match the sign here. So I would say in an example where you're doing it yourself, I would definitely make it negative if that was negative. But right now we'll leave it alone. So let's do each one. We have negative 18 x to the 5th over 9x to the 3rd. And we have 63 x to the 3rd over or divided by 9x to the 3rd. Negative 18 over 9, or divided by 9, is negative 2. Better know your positive negative rules. X to the 5th over x to the 3rd. You have x, 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 x on top, and you have x, x, x on bottom. We're left with x to the 2nd. Positive 63 and positive 9, so this will be plus. 63x to the 3rd over 9x to the 3rd. The x to the 3rds reduced down to a 1. Adios. 63 divided by 9 is 7. So, final answer, negative 2x to the 2nd power plus 7. And that right there is how we either divide, reduce, or simplify in a situation where we have a polynomial divided by or over a monomial. Other vocab I brought up was the phrase rational expression, meaning it's written as a ratio. These are polynomials. In fact, I happen to just focus on binomials. We can use terms to words to represent what type of term it is. For example, this is a cubic term. We call this a quadratic term. So is that and that. X, or x to the 1st power, represents a linear term. Another cubic and cubic. 5th degree can be called the quintic term. And if we had a 4th degree, it would be quartic. And a number like 36 or 9 that is essentially x to the 0 next to it, because x to the 0 is 1. So we can just kind of keep it invisible. Those are known as constant terms. So those are words that maybe you should write down, acknowledge, and make sure that you know. We also mentioned descending exponential order. We also mentioned standard form, polynomial, monomial, binomial. If we had 3 terms, it would be called a trinomial, and anything bigger, polynomial of 4 terms or 5 terms, 6 terms, and so on. And I think that's everything I wanted to talk about in this video. So if you understand, you feel good, thumbs up. If you think I'm crazy and you need more help and you need harder examples or easier examples, thumbs down, and sound off in the comment section underneath. All right? Wishing you the best. Come on back for lesson 5, which is prime factorization of factor trees. I know it might sound babyish and silly, but it's actually super important. Okay? Thanks.